I said 2 levels of understanding. So the first, the rough level, then fine level. Yeah. The first level, so remember we can modify the given questions to make it simpler, right? Yeah. So that kind of idea strategy we use many times. This time our modification is here. This condition. It is known that x6 is not the minimum. So can we skip it first? Yeah. The first round we skip it. So we do not permanently skip it. So we temporarily skip it. Yeah. Then the question should be easier, right? So without this condition, how to find the solution? All right. Now let's solve this modified version, rough version. All right. First, 8-element array. Our data is an 8-element array. First question, is this number 8 important? Why this 8 number important or not? Okay? Yeah? So that's another special way of thinking in problem solving. The data size. The data size number, here we use 8. Is that 8 very special? Do we have to use this number 8? Can we change this number 8? Right? Yeah, that question. Yeah, many times. This kind of thinking helps. So the idea of changing the data size. Data size. Okay? All right. Think about it. Can we reduce the data size from 8 to 7? Right? Yeah. So here, reduce the data size. We know in general, when we reduce the data size, the problem becomes easier, right? Yeah. In general. Not 100%, 90-something%, but still pretty good, right? 90-something% correct, still pretty good. Yeah. Because that way we can make our problem a little easier, right? Yeah. So let's try that way. Right. Original problem size 8, can we reduce it to 7? 7-element array. And we want to find one element inside in this array that is not a maximum, not a minimum. Neither maximum nor minimum. We can, basically the same question, right? Yeah, you can see similar question. If that's from the difficulty level almost the same, can we reduce the size another time from 7 to 6? Reduce one more. Yeah, because it looks like the size is not that important here, right? The size is not that important. Yeah. How about reduce another one? How about reduce as much as we can? How about that? Okay? Yeah? Because in this way, we can make it easier and easier. Why you reduce? Because we want to make it easier. Right? Yeah. How about reduce to another round, 3? In a 3-element array, can you find one element in it? that is not the maximum, not the minimum. And how many comparisons do you need to do that? That question should be very easy, right? Yeah. 3-element array. Because after 3, you cannot reduce one more, right? 2, then you bring the problem, right? Yeah. Your data is too little. So the question does not make sense. If you reduce the size further, the question does not make sense. Because other than the maximum, other than the minimum, you have nothing left, right? So the question does not make sense. In order to make it meaningful, right? In order to make the whole question meaningful, you need at least size 3. All right. So now for size 3 question, when you solve the same problem, how many comparisons do you need? 3 comparisons. 3 comparisons, what do? You basically sort it. Because when you sort a 3-element array, you need 3 comparisons for the worst case. And not the best case. For the worst case, you need 3 comparisons. Okay? Yeah. After you sort it, you pick the median. The median satisfies the requirement, right? The median is not the maximum. The median is not the minimum. Median is different from max. The median is different from min. Right? So that's the solution. So when you have a 3-element array, you can solve the similar problem easily with 3 comparisons. Okay? All right. Now because after you make modifications so many rounds, at the end, you need to go back to the original question, right? Yeah. So our golden rule, after we solved some easier versions of the original question, we need to go back to the original. Now let's go back to the 8-element array. When we go back to 8-element array, now, if I ask you to find one element that is not the maximum, not minimum, how many comparisons do we need? Okay? Yeah. How many elements do you need? Right? Yeah. Yeah. Still 3. When we go back to 8 elements, still 3. Why? Because you just pick a 3-element subarray. You just pick 3-element subarray from the original array, arbitrary 3 elements from the original array. Then you find the median of the selected 3 elements with 3 comparisons. Then that local median, right? Yeah. So that median we call that's our local median. That local median is a solution. That local median cannot be the maximum, right? That local median cannot be the minimum, right? So that local median is one of the solutions. That's the rough level, okay? Solution. 3 comparisons. You never need more than 3 comparisons. The maximum number of comparisons you need, it's 3. Okay? The worst you can do is 3. All right. Yeah. So that's the first level. Second level, yeah. So I need more space. Yeah. Whatever. Yeah. The space is not enough. Okay. Yeah. Anyway, Later, I just borrow some other spaces. If I out of space, I just borrow, other places, empty space. Yeah. All right. So, let me complete this one first. Oh, I need to scroll down. The bar. Oh, I cannot move down the bar. I need a keyboard to move my scroll bar. All right. Yeah. All right. Yeah. Here. Yeah. Now, so we are at the second level, 2 comparisons. Now we want to improve 2 comparisons. Yeah. Let me use the space here. Borrow some space here. Okay. So this time we have a condition x6 not equal to the minimum. We want to use, because this information is useful. Okay? Yeah. We hope this condition can help us reduce the number of comparisons. Okay? Yeah. Reduce from 3 to 2. Sorry. Yeah. Our target, because right now we have the 3 comparisons solution. So our target is 2 comparisons. Otherwise, we just take that 3 comparison solution, right? Yeah. But now we want to do a little better. So we target 2 comparison solution. All right. The question, how to do it? Then the analysis part, the thinking part. Yeah. We need, so here, our resource. These 2 comparisons, that's our resource. Very precious resource. So we should not waste our resource. When we use each comparison, we should explore the maximum amount of information from that comparison. Yeah. That's the, our intuition to drive our thinking. All right. So when we apply first comparison, the first comparison is important. The first comparison, we want to get maximum amount of information from the first comparison. All right. Yeah. So when we apply the first comparison, because we have several ways to apply first comparison, right? Yeah. So look at our data. 1, 2, 3, many, but the X6 is special. Yeah. It is special. All right. When we apply our first comparison, typically there are 2 different ways to choose our first comparison. The first way, X6 not involved. And the second way, involved. There are 2 different ways. Not involved or involved. 2 different ways. And we want to find it out. Involved way or non-involved way, which way would give us more information? That's the criteria to help us make our first decision. What comparison to choose as our first comparison? Without x6, we do one comparison. Is this way can give us a little more information, or we compare x6 with any of the other elements? The second way would give us more information. That decision is critical here. That's the critical decision. The answer is not involved way is better. We would get more information, not involved way. So why? Yeah. Let me explain why. Because if it's not involved, you have no restriction, right? Yeah, because not involved when you select two elements. No restriction. Okay? What's the no restriction? Because you pick two unknown elements. You pick arbitrary two unknown elements. You do one comparison. Whatever you do, whatever result you do, you will not impact any other information, other known information, right? No impact to other known information. All right. Then let's look at the involved case. Involved case, you select x6. Because x6 contains some known information, right? Yeah. So this is the known information. x6 not equal to minimum, this is the known information. All right. In your first comparison, you pick a known element or partially known. x6, we can say partially known, right? It contains some partial useful information, known information. But if your first comparison has x6 involved, you have two possibilities. Greater than, equal than, greater than x6 or less than x6, then that comparison result will mix with the known information, right? Yeah. Because x6 has some known information. Then you add some more information to the known information pool. Yeah. In that case, at least, the information gain part is not the maximum. The information gain part. Yeah. Because the two part mixed together, the information part is not a maximum. But here, if your first not involved, then the comparison result is completely useful. Completely useful. The gain, the one full comparison, that information, that's the gain. But with x6 involved, you get a partial gain. Yeah, because there is some interference, right? Yeah. No information and a new comparison result, there is some kind of interference you need to consider. So the gain is not the maximum. So for that reason, our first comparison, we will select arbitrary two elements other than x6. Let's say x1, x2. x1, x2, yeah, we can make assumption. x1 less than x2. Less than x2. All right. Less than x2, then the second comparison now. Because this condition is completely unrelated to that x. So in our second comparison, this time we need to use the x6. Second comparison. All right. Second comparison, we can choose one of the two, right? x1, compare x1 with x6 or x2 with x6. You have two options. So you can try each one, right? Which one can give you the solution? Then you take it. Two options. That's not too many. So when you try, you will see. When you pick x2, you will get a solution. Okay, all right. When you pick x2, only two cases. The first case, x2 less than x6. In this case, x2 less than x6, x2 is the solution, yeah, because x1 less than x2 less than x6. So x2 is the solution. In the middle, not the maximum, not the minimum. All right. Then, second case, x2 greater than x6. Then x6 is the solution. Why? Because x6 is greater than the minimum. It's not the minimum, so you can use it, right? So x6 not the minimum, and x6 with this inequality, x6 is not the maximum. Then x6 is the solution. Then you can find the final solution. Two comparisons, you can find the final solution. Okay. So that's the analysis part. Yeah. So think about that. Yeah. The problem thinking. Yeah. Two levels. Yeah. The first level, the second level. Yeah. This kind of analysis in problem solving. Try to learn. Yeah, try to learn this kind of method. Yeah. So here you can see our understanding is so important. The level of understanding. If you can understand in a deeper way, very deep way, then you can do a better job. This one is an example. All right. Yeah. So we complete this one. Next, two. Yeah. So number 24. Yeah. Number 25. Yeah. Number 24, 10-element array. Yeah. And a two-ordered subarrays. Two small-ordered subarrays. And we need to find largest, smallest, second largest, second smallest. All right. Yeah, so here, let's do two steps. The first step, just the largest and the smallest, relatively easier. Yeah. So we leave the, this is the first round. Round one. This is the round two. Yeah. If you can do round one, yeah. So in the final, when you, here, let me give you some suggestion, because you want the maximum number of points to earn in the midterm. So for hard questions like this, if you feel you cannot completely solve the question, then try your best to solve partial question. For example, for this one. If you feel second largest, second smallest too hard to solve, just to solve part of it. You just find the largest and the smallest. At least you can earn partial credit, right? Yeah, yeah. Because some students lost all the points. All the points. Yeah. So if you feel you couldn't get a solution, so then just get the part that you feel you can do. Yeah. Largest, smallest. I think you know how to do it. Yeah. All right. So here, let's do this the first part. Largest and smallest. Yeah. For this part, yeah, in the data, yeah, because this part we need to apply the, our elimination method. All right. Yeah. So look at the condition. X2 and X5 can be eliminated, right? Yeah. Because X2 cannot be the largest and the smallest. X5 cannot be largest and smallest. So X2 and X5 are eliminated immediately. So we reduce the problem's size from 10 to 8. So for the first round, we already reduced the problem size from 10 to 8. Okay, all right. Then, largest, smallest, we learned a similar question before, right? Yeah. We solved a similar question. Let's just repeat the same analysis part. Yeah. So I think you're familiar with that part. All right. Yeah. To repeat that part, tournament method, right? We pair all the elements. Here, 10 elements or 8 elements, even number, right? Yeah. Even number, so we can pair all the elements. The first pair, X3, X1, we already know the order. The second pair, X6, X4, we already know their order. Then the remaining 2 more pairs, we do not know the order, right? Yeah. So let me use the, different notation. Yeah. So next pair, X8, X7. Yeah. Let me use this. Yeah. So we need to do comparison to know their order. The last pair, 10, X9. Yeah. All right. Comparison number 1, comparison number 2. So then the winners group, right? Losers group. Same as we did in our, old question. Find both maximum and minimum. Yeah. So the winners group for max. Losers group for minimum. Okay? Yeah. Find the max, we need 3 comparisons, right? Find the minimum, we need 3 comparisons. So for round 1, find the largest, the smallest, 3 plus 3, and 2 early comparisons. So total 8 comparisons. All right, total 8 comparisons. All right. So that's the maximum minimum. Yeah. Then the second round. So that's the hard part. Yeah. Yeah. Second round, that's the hard part. So we need to do some deeper analysis work. Deeper analysis. All right. So this deeper analysis, so let's consider the candidates. For second largest, smallest. All right. Because largest, smallest symmetric, right? Largest, smallest symmetric. I only need to do the largest analysis. The smallest part, we just do similar analysis. Yeah. Symmetry. All right. Now let's consider the candidates. What are those elements they are qualified to be the second largest? So we put them together in a group. Then we will find the largest element in the candidate group for the second largest. That's the idea. Okay. All right. So we need to, examine carefully. Yeah. We don't want to miss any possible candidate. All right. So we need to look at all the elements, other than maximum, minimum. Maximum, minimum, we remove them. Maximum, minimum. Okay? Eliminate. All right. Then let's look at all possible candidates. When you look at the candidates, should we bring back x2 and x5? Because in the first round, we eliminate these two elements for largest and smallest, but they are still qualified to be the second largest or second smallest, right? Yeah. So when we consider candidates for the second round, we need to bring back x2 and x5 first. Yeah. We don't want to miss any possibility. Yeah. All right. So when we bring back x2 and x5, because these two elements are special with respect to other elements. These elements, they have some special information, properties. Yeah. All right. So, but the x2 and the x5 similar, right? Yeah. So we may like to compare x2 and x5. Yeah. So that's we already used the 8 comparison. That's our comparison number 9. Okay, that's our comparison number 9. Okay, yeah. All right. Comparison number 9. Yeah. And we can assume one is larger than the other, right? Yeah, because they are symmetric. Yeah. So let me just put x5 up, x2 below. Okay. Yeah. That's our comparison number 9. Right. Yeah. There. Because after we use one comparison here, an immediate consequence from this comparison is x5 is qualified for the second largest, but x2 is not qualified for the second largest, right? Yeah. Because it is the loser to x5. X5 has chance to be the second largest, but x2 has no chance to be the second largest, because x5 is larger than x2. Okay, all right. But x2 is qualified for the second smallest. So then we separate. Yeah. So we can put x5 in the candidate group for the second largest element. We can put x2 in the candidate group of the second smallest element. Yeah. The candidate. 2 candidate groups. Yeah. All right. Other than x2, x5, let's look at the others. Yeah. Let's look at the early winners group, the first round winners group. First round winners group, we run tournament method. Yeah? Because when we find the largest, we run that tournament method. all right? Yeah, for these two groups. Tournament method, okay? All right. When you run tournament method like this, that's the max, okay? Max, you take it away, all right. After you take max away, let's look at the candidate in this winners group from the first round. What are the candidates? The candidates, the direct loser, suppose this is max, direct loser of that max. Because for the indirect loser, not qualified for the candidate, right? Only the two direct losers are qualified to be the candidates. Yeah? Because this indirect loser, it lost to one element that is beaten by max. So it's too far away from the second largest, right? Yeah. Still, there is a distance between this loser and second largest. So this is not qualified for the candidate. So you can see the largest number of candidates, 2 from the winners group, right? So this winners group, other than X5, so 2 more from the winners group. 2 more from the winners group. Okay, all right. Then, because we want to find out all the possible candidates, so we need to look at everywhere for possible candidates for the second largest. So other than the winners group, we need to look at in the losers group. In this losers group, is it possible there exists some candidate in the losers group? We need to explore. The answer is, if the winner is X10, then this direct loser, or here I want to call it initial loser, yeah, because I want to use a different name to avoid confusion. All right. So this X9, yeah, because the initial round comparison. Yeah. So let me try to use a different name to separate. So initial loser of the winner of the max, let's say max, yeah, because we have too many winners. So let's look at the initial loser of the max. Is it possible candidate? Yeah. Although it is in the losers group, but it only lost to the max once. So it has a chance to be the second largest. So we should put this element into the candidate group. So 2 more plus X5, then plus 1 from the losers group. So you will see there are 4 candidates. For second largest. 4 candidates. Okay? Yeah. That's the maximum number of candidates we can explore. Yeah. We dig out maximum number of candidates. 4. Okay? No more. No more than 4, right? Yeah. No more than 4. All right. Yeah. So after these 4, yeah, we know the maximum of these 4 elements, that's 3 comparison. 3 comparison to get a second largest, to get a global second largest. Yeah. Similarly, 3 more comparison to get global second smallest. Yeah. So that's the reason it is pretty hard, yeah, challenging. Yeah. because the second to last question. Yeah. The higher the problem numbers, the harder the question. The second to last. So, supposed to be hard. Supposed to be hard. All right. Yeah. So then, total. So now we can calculate total. Wait. First round, we have 8 comparison, right? Yeah. 2 plus 3 plus 3. Second round, we need 3 and plus 3, right? Oh, and 1, right? Yeah, because between 2 and 5, we need one comparison. Okay, yeah. So plus 1, 15. 15. That's the best we can do. Yeah. A lot of analysis work. Yeah. But if you can do part of it, yeah, sometimes, yeah. So you just take, the maximum that you can do. Yeah. Even 2 points, pretty good. Yeah, total 4 points. So for the hardest questions, if you can get 2 points, that's still quite good. Yeah. Yeah. So that's question number 24. Yeah. All right. The last question, this one. Yeah, we have quite some space. Yeah. The last one, the hardest. Yeah, the last one hardest. Yeah. Most challenging one. Yeah. So because I want to see how much, yeah. Even if you can not solve it completely, yeah, just try the best you can. Try the best you can. Yeah. Yeah, this one, yeah. Really the hardest. Yeah. But in this situation, the hardest case, yeah. So usually we try the best we can. Yeah. Yeah. You do not, yeah. If you cannot find a perfect solution, just do partial solution. All right. So here, usually for the hardest question, I want to use 3 different versions of solutions you can think about. So here, let me give you 3 possible levels of solutions you can think about. Yeah. All right. The first one, weak solution. Weak solution. Yeah. So that may not be the best solution. Yeah. Weak solution. Yeah. Yeah. But you want it very close to the solution. Yeah. So the weak solution, usually we use this one more comparison than the standard solution. So for this question, weak solution is 11 comparison. If you can use 11 comparisons to find a solution, then it's a weak solution. Weak solution means you earn 3 points. If you can get a weak solution, yeah, 1 point off. Yeah. Full credit, 4 points. So weak solution, 3 points for weak solution. If you can use 11 comparisons to find a solution, you earn 3 points. That's pretty good. Yeah. Only 1 point fewer than the standard solution. Second version is the standard solution. Ten comparisons. Full credit. So 4 points, full credit. Okay, all right. Standard solution. So you need to do more work to improve by 1 comparison. But the third one, there is a possibility. Because sometimes some students can do even better than the standard solution. So we call it a strong solution. Strong solution, if you can solve it by 9 comparison. Strong solution. 9 comparison, so other than the full credit, I will give you 2 bonus points. 2 bonus points. Okay? Yeah. 4 plus 2, you get 6 points. Yeah. So 9 comparison, but your solution must be correct. Yeah. So I need to read your logic carefully. Yeah. So if I see, everything is correct, so then you get 2 bonus points for a strong solution. Okay. All right. Now here, let me talk about the weak solution. Yeah. Weak solution. It's pretty easy. We can use 11 comparisons to find solution. Yeah. Yeah. But for the standard solution, that's pretty hard. Even if you improve just by 1, so very hard. Okay. Yeah. Yeah. All right. So let's look at the weak solution first. All right. Usually, for the weak solution, we do not need to apply very complicated techniques, manipulations. Yeah. We just apply some ordinary steps, not the fancy steps. Fancy steps, so usually you need to use them in the standard solution. Standard solution, you really need to make some unusual effort. Yeah. Strong solution, you need to have some very smart idea. Yeah. Very smart. It's very hard to find. So those ideas, very hard to find. Yeah. In that situation, you can get a strong solution. All right. So for the weak solution, we have this 4-element ordered chain. Okay. All right. X5 is here. All right. Another 4-element ordered chain. Then X10 is here. All right. First round, we just do binary insertion. Yeah. Because when we do insertion, we know binary insertion is better than the sequential insertion, right? Yeah. So we do binary insertion. Yeah. Here also we do binary insertion. Okay. Yeah. But the binary insertion here not too efficient, because this step we need 3 comparisons to get it inserted, right? Yeah, because 4 elements, binary, we can only save one comparison. Yeah, because you compare the second or third, then you need 2 more. After your first comparison, you still, for the worst case, you need 2 more. So 3 comparisons to get X5 inserted into the ordered array. Here, insert X10, 3 comparisons to get X10 inserted into the ordered chain. All right. After that, you have 2 ordered 5-element chain, right? Yeah. 2 ordered 5-element chains. So you move to next round. Next round, from 2, so here I just draw, show you some idea. First ordered 5-element chain, second ordered 5-element chain, right? Yeah. Now we need to find the median, fifth smallest. So we do it from the smallest end, from this end. This is the smallest end. Yeah. Smallest end, we need to find the fifth smallest. How to do it? The first comparison between the two smallest in these two chains, after one comparison, we get the first smallest. That's one comparison. Okay? Yeah. Then, if one is winner, one loser, that is the first smallest. The winner, we compare it with the next element in the chain, in order. Okay? All right. So, second smallest, second comparison. Each comparison, we put one element in place. So, third, fourth, fifth. So 3 comparison, 4 comparison, 5 comparison. Okay? After 5 comparison, we get this fifth smallest. Okay? Yeah. So in this second round, we need 5 more comparisons. Yeah. 6 from the first round and 5 from the second round, total 11 comparisons. Yeah. That's our weak solution. This is the weak solution. Okay, yeah. So that's 3 out of 4 points. Yeah. Yeah. So if the question is too hard, you just set your goal to weak solution. That's pretty good. Weak solution. Yeah. But to get a standard solution, you need to do a lot of work. Yeah. At this point, actually, I do not know how to do the standard solution. Yeah. So in my solution file, I will put some related example. So I put there. Yeah. So I'm thinking about that, try to figure out standard solution. Yeah. But if you are interested, so you can try to improve by one comparison. It is still an open question, all right? Yeah. So the standard solution. Then, the strong solution. That's really hard. That's just, sometimes it may not exist because we don't know if the strong solution exists or not, right? Yeah. Yeah. But the standard solution, it should exist. But I cannot say 100% sure. Yeah. Yeah, because this solution is too rough. The binary insertion here, too rough. So definitely we have room to improve by one comparison. Yeah. But not easy. Not easy. Yeah. All right. Yeah. Let me stop right here. Yeah. So we finish this review session. Then I will post part of B, C together, the second assignment. Yeah. Part A already there, yeah, but you are able to see it at 8 o'clock. Yeah. Before 8 o'clock, it's invisible. Yeah. It's invisible. Yeah. But after 8 o'clock, then you can see it. I can use this, 10-something minutes. Let me post second part, computation part. Yeah. All right, so that's it.